Hello everyone, this is Hani and welcome to my channel. Today I am going to start the lecture number 7 of the course MATLAB for beginners, and today I'm going to show you how to plot your data using the 2D plots of MATLAB. So let's get started. Before we use the 2D plots of MATLAB, we must have some data to plot. Okay, so first of all you have to have some data. So I'm going to start with the vector y, just like that. And to generate a vector y, we can have many functions to do that. First function, for example, or first way to do that, for example, is just to have the initial point and step and the last point. So we can have a vector in this way, and this vector is a linear vector. It means that we have the same step size and there is no change in the steps, right? And this is one way. Another way is to use the function len space or lin space. So this function is written just like that, lin space, right? And it takes 2 or 3 parameters. I'm going to show you how to use the 3 parameters. So we start at one point and the end points, and then we provide the number of points between 1 and 100. Okay, so if we say 100, then we have 100 points between 1 and 100. And you could do this in the same way with the colon operator. So you can use both of them. And also you can use some of the functions that generate some of the matrices. For example, we could use the ones function. So we can have ones for a row vector. So I'm going to write 1 here and 100. Okay, so this is a row vector that contains 100 columns or 100 elements, each of which contains a value 1. The most interesting one is the rand function, which generates random numbers. I'm going to say y assigned rand of 1 and 100. So this function generates a row vector because we have this is a row and this is a column, so we have 1 row and 100 columns. So we have a row vector of 100 elements, all of which are random numbers between 0 and 1, right? If we want to increase the range, we have to multiply by 10, for example, or 100. So if we want numbers between 1 and 10, then we multiply by 10. Okay, just like that. Okay, so y becomes those values. Okay, so we have a vector now that contains some values. Those values are random. Okay, and we want to plot that. I'm just going to write some comments here first. If we want to plot a function or we want to plot some data against some other data, they have to be like a function. Okay, so a function y is a function of x. What does this mean? It means that the variable y that we have is a dependent variable on the variable x. That means that x can move in any direction or with any values, right? But y should follow x. Okay, so for example, if we have y equals x squared, okay, that means we change x and then we detect y. So y is determined by x. If we have, for example, x equals 1, so y is 1. If x is 2, y is going to be 4, and so on. So x is the independent variable and y is a dependent variable, right? So in our case, to plot some data, we have to have x and y, okay, or 2 variables. One is independent and one is dependent. So if we have some data like this, we can plot y assuming that x here is the ordering of y. It means we have 100 values of y, okay? So MATLAB generates another vector x that you don't see. This vector contains the elements 1, 2, 3, 4, 5, etc. until you end with 100. And let's name this one x. When you ask MATLAB to plot y, it basically plots x and y, this x, right? So it plots x or the ordering on the x direction or coordinate, and the function y that we generated or more specifically, the data in the variable y that we generated, it's going to plot it on the y-axis, right? So let's try this. Okay, let's just say plot y. And to show the plots or to have some graphs plotted, you have to use the function plot. So plot y, just like this. Okay, so when we do that, we have this figure here. This is the x-axis and this is the y-axis, right? There are no labels yet. Okay, and you have the data, even though they are discrete points, okay, because we have separation between them, but we have them connected. If we want to show them in a different way, we could do that by specifying the shape of the points or the markers. Okay, so I'm going to do that. Okay, so let's close this and write plot and then comma, plot and then y and then comma, and then here in this string I'm going to specify the marker, the spacing, and the color. Okay, so for the marker I'm going to have star just like that, or asterisk, and then we have the spacing between the points is going to be a line, and then R for red, and you can change this to blue or black or whatever. Okay, you just need to know what letter you need to use. Okay, so I'm going to plot this so it looks just like this. Okay, so now we know that we have some markers for the points. So this is 1 point, second point, third point, and so on. And then you can see here that for this point, x is 1 and y is 5.2114, and for this one, x is 2 and y is 2.3, and so on. So you can see here that x is taking discrete values with constant spacing. The spacing is 1. Okay, so it seems to me like x is just like that. It's just the order of the points y, 1, 2, 3, 4, 5, 6, or the index of the points y. Okay, so this is how we plot them. Or we could have a vector x and we can generate it just like that, and we can say 1 and 100, and the number of points between them is 100. Okay, and then we can say plot x, y. We have to start with the independent variable first, so x and y. Okay, if we say just y, so MATLAB assumes that you want to plot y against the order. Okay, otherwise you have to first have the independent variable x and then y. So let's see. So this is our curve. So for now, what I want to do, I want to have x label, y label, and then a grid. Okay, so I'm going to write here x label. Let's assume this is time and it's in seconds. Okay, so you can see here it's written time in seconds, right? Now I'm going to use the other function, which is y label, and it takes some values, and for y I can just say the distance and in meter. Okay, and then enter. So we have here the label for x and the label for y, and I'm going to add the title. So I'm going to have figure 1, for example. Okay, so we have a title, distance, time, and the title here is in bold. Okay, I'm going to add the grid, so I'm going to just say grid on. So we have grids now. Okay, and I'm going to add legend. So legend is going to be legend, and I'm going to give it a text, distance, time, for example. So we have that. So we have a legend, we have the time label, we have the x label, y label, and then the figure title, and then we have the grid. This is mostly what you need to do, or what you need to have in a graph or in a plot. Okay, we can do some modifications to this plot. I'm going to show you how, but this is basically how you could do it in MATLAB using the command line. Before we adjust our graph or our plot using the figure properties, I'm just going to show you how to plot multiple graphs in the same figure. Okay, so I have two commands or two sets of commands that you can use to have multiple or more than one curve or plot in the same figure. Okay, so it's hold, okay, or hold on. Okay, so the difference between hold and hold on is, if you call hold once, then you hold this graph or this figure so that you can plot again on it. Okay, and if you call it twice, then you release this figure, okay, or this plot. Okay, for hold on, you can release it with hold off. Okay, so I'm going to use hold for now. So you can see the message here saying current plot held, and you can plot as many plots as you want. Okay, so if I have a function y just like that and the independent variable x, we need to generate another variable or a set of data, maybe z, that depends on the independent variable x. Okay, so I'm going to create z as x to the power 2. Okay, and if you want to know why we're adding this dot here, I mentioned this in a previous lecture, but basically to have element-wise power. Okay, so that instead of having the X matrix multiplied by itself using the definition of the multiplication by linear algebra, we need to have each element of X multiplied by itself, right? So that's why we use a dot here. So this is going to be Z. So you can plot Z, X and Z now. So I'm going to say plot X and Z. And you can see here that I don't have to have the marker and the spacing. So I'm going to plot this on top of the other one. So you can see here that I'm having my graph in blue and red. Now you cannot see here any data for the blue because the range of the data in blue is between 1 and 10, and for this one is between 0 and 1000, right? So to adjust this, first, if you want to see them, you can just zoom here. Okay, you need to zoom enough so that you can see the blue data, but otherwise you can divide that by the range, by its range. Okay, so if the range is 10,000, you can divide that by this, or multiply x by 10,000, right? So I'm going to just close this and redo it. So plot x again and y, and okay, and then hold, and then plot x, z. Now z is going to be multiplied by, and I could do this, or divided by 10,000, and I'm going to have red for that. Okay, so I have the data for the z variable, okay, and the data for the x variable. Okay, and I can have another one, so I could have plots x, and instead of having a variable to hold the data coming from x, I can just plot x times sine of x, right? And then I'm going to give it the color black, so it's k. Oh, I need to have maybe this. Okay, so now I have the function in black. This is basically how we plot several functions or several data sets on the same figure. Now if you want to stop doing that, so you can just release this hold. So I'm going to just say hold again. So if you write hold again, it's going to show you this message here saying current plot released. And then if you plot another function, okay, now you have your plot here. If you plot again, these plots are going to be removed and other plots are going to show. Okay, so x and x dot star cosine of x again. Okay, and I'm going to take C. So we have here the data, and since the plot is released now, you cannot see anything other than these data. And then I'm going to switch now to the editing. Okay, and before we do that, I'm going to plot some other data first. Okay, so let me clear my screen. I'm going to use x and y and some other functions. So I'm going to redefine z. So z is going to be, for example, x times y. Okay, for now. And again, this symbol here means, or this operator here means, we are performing element-wise multiplication, which means that each element in x is multiplied by its corresponding element in y. Okay, so this is it. And then we are going to plot first x and y. Okay, so this is x and y, and we can have hold on. Okay, so if I want to release the figure or the plot, I need to have hold off. Okay, so hold on and then plot x and z. Okay, so I have two curves here. One is blue and one is in brown, I guess. And let's have another function. So I'm going to plot x and okay, so I have the three curves here. Now I'm going to use the figure properties from here so that I can change the colors and the attributes for these plots. I'm going to go to the edit menu and then choose figure properties from here. I'm going to show you how I use it. Okay, so I'm not going to use everything here. Whenever I want to change something here, I need to click on it. So I'm going to click on this box here. Okay, so when I click on this box, I can see the X label, the Y label, Z label, for example, and the title. Okay, so I can change the title here, and this title is going to be figure 1, for example. And then if I click again on the box, I have X label. And X label is going to be time. For all of them, okay, it's going to be time in second. Okay, right, we have the time here. For Y, I'm not sure what we have here. We might leave it just like this because we have several plots. Okay, so the independent variable is a time, but the data are different. Okay, so I'm going to leave it like that, but instead I'm going to have some legends, right? If I want to add grids, I'm going to click again on this curve or this box, and then I'm going to go to grids. Okay, so grids here. I want one for X and one for Y, right? I can change the color here so that it becomes blue, right? Or red, for example. Okay, so let's for now stick with gray, let's say. So this is what I typically do. Now I can change the background color, box styling. Okay, so color here is white. I'm going to give it a little bit of a different color. I can go with this color. Okay, if you don't know how to get this color from, you can just click here and choose what color you want. Okay, so I'm going to go a little bit just like that. Okay, so I have now my curve or my curves on this figure. Okay, so let's go to font now, and then I'm going to have, let's say, 14. Okay, and bold. Okay, so this is going to change it, right? If I want to change these texts to start at certain values, we need to go to text here. For the X text, for example, we have 11 elements, so 1, 2, 3, 4 up to 11. Okay, we could change this so that, for example, we can have 5 here, so 0, 5, 10, and so on. Okay, the spacing is going to be the same. So if I go to text, X texts are going to have 11 elements. I could add 0, 5, 10, 20, 30, and then maybe 35, and then 40, 50, 60, 70, 60, and then we could skip 70 and have 75, and then 80, 90, 100. If I do that, now you can see that starts at 0. 10 is going to be at the same position or at the same spacing, okay, but we have in between 5, and then 20, 30, and then 35 between 30 and 40, and then 50, 60, and then there is no 70, 75, and so on. Okay, so you can change this if you want. Normally, for me, I leave it just like MATLAB does it, so I don't change it a lot. Okay, you could do the same for Y, so you can change it here. Okay, so it depends what you want to do. If I click not on the box but on the curve itself, just like here, I can change it. Okay, so I can change this color, for example, to red, just like now. Okay, so we have red, and I can change the size to 2, and the line style here is just a single line, just like that. I can have it as a broken line, okay, or other things, just like that. Okay, anyway, I like to have it just as a single line, and I can have a marker. There is no marker here for the red curve, so I can have a dot marker or star marker or X or square. Let's add square marker. So this is what I have. Okay, and for the yellow one, I can change it to blue again. Okay, line style, could leave it just like that, or maybe just like that, it's fine. And then I'm going to have circles as markers. Okay, and the size could change to 1. Okay, and then we have the last curve. I'm going to change it to green, the size to 2.5. Okay, and then I can have star markers, and we could change the marker size, so it could be 4 for example. Okay, right? So basically this is what I do in the plots. There are many other things you could do, but this is for me more than enough. Okay, it depends on what you want, but you could read about all the options, or you could search for the help on them to know how to do the plots. Okay, now I'm going to insert legends, so I'm going to close the figure properties from here, okay, and then insert legend. Okay, so now I have data 1. I can move it from here to here, for example. I have data 1, data 2, data 3. If I click on it, I can have for data 1, let's say this is distance, and for data 2, voltage, okay, for example, and for data 3, you can have temperature, just like that. Now let's move to the next topic for today, and it's going to be the subplots. So we use subplots if we want to have multiple graphs in the same figure, but each of which are separated like in a matrix form. If you want to have a subplot, you need to use the function subplot, and it takes 3 arguments. The first one is how many rows in this plot, so let's say 3, and the second one is a number of columns, so we can say 2, and the last one is where you want your plot, so let's say 1. Okay, so if I do that, then I'm having 3 rows, 1, 2, 3, and then 2 columns, and my plot is going to be here. So I can plot any function. So if I have x as 1 to 100 and y as x to the power 2, right? Then since I wrote this call here for this function, I am already on this plot or subplot. So I can just plot x and y and give it the color. Right? So I'm here. Now I can move to another subplot. So 3, 2, and 2. Okay. And then let's see, I'm here and plot x, and let's say x to the power 3 and blue, right? Now let's add a third one. So plot, before we do that, we need to change to the subplot that we want. Subplot, and then again 3 and 2 and 6. 6 is the subplot, the last subplot here, this one. Okay, and I'm going to plot y with y times x, and then we can have black color, K for black. Okay, so let's see. Okay, so we have these three figures in this subplot matrix, and we can add here one here and one here. So this is going to be 3, 2, and 3, 3, 2, and 4, 3, 2, and 5, right? Now, if I want to change any of the parameters or the attributes of this graph or plot here, I have to select it. How to select this one? By calling it. So I call this function subplot and 3, 2, 1. Okay, so this is a current one. Now I'm on this plot, right? So I can make some changes now. So for example, I can say x label time. Okay, so you can see here that we have the x label set to time in seconds, and you can have grid on, for example. It's going to be selected for this graph only, and basically you could do everything we have done for a single graph or a single plot. It's only a matter of selecting which subplot you're working on now. Okay, and again, you could also choose the figure properties from here and select this one and start to edit it. So that's all about the subplot. And now we move to the last topic in today's lecture. Let's first close this figure here. So just to let you know, we can close the figure also from the command line. So we can just say close all. So this closes the figures that we have. If we have like 10 figures, all of them are going to be closed at once. Okay, so close all. Now we don't have any figures. We are going to use a function. It's called draw now. This function is used when you have a continuous output and you want to show this output in real time. So first let's clear the workspace and then clear the screen. And for this topic, I'm going to create a script here. So this script, I'm going to name it example. This is only a few lines of code. First, I'm going to create a figure. So we haven't done this before, but it's useful to create a figure, and maybe you also could give it a name, just like this. Okay, so if you want to work with multiple figures, you can create a figure and give it a name, and then you plot on this figure. And if you want to switch to another figure, you just call this function again and again with the ID or the number. Okay, and then I'm going to hold this figure. Now I want to draw or plot to this figure continuously. Whenever I have some data, I want to plot them. Let's say we are having a for loop in which we run some codes and get some data, retrieve some data. For I from 0 to 2 pi, and then end. And let's draw some sinusoidal function. So we can draw a plot I and sine of I, right? If we just leave it like that and then we run this code, we are going to see the points just here. Okay, now I want to use this function draw now. This function is drawing point by point as soon as they are computed. Okay, so whenever the I is computed, they are plotted. Okay, so if we run now, you cannot see the difference, but you should have something like this. This point appears, and then this point, this point, this point, and so on. To see this effect, we need to increase this factor here, that is multiplied by pi, and we need to have a step size that is a little bit small, so 0.1. Okay, so now we are moving 0, I is moving from 0 to 2 pi and increases by 0.1, and we can make this 4 pi. Okay, let's see. Now you can see it's plotting point by point. I is initially 0, and then you compute this function for I, which is now 0, and then you compute sine 0, and then you plot this point, and using this command or this function here, you force this point to be plotted, and the figure updates now. Okay, and then you repeat this again and again and again, and each time a point is computed, this function is forcing this point to be plotted to the figure. Okay, again, if you decrease this step, or increase this one. So let's make it 20 for now. We are going to see a longer time period in which the whole curve is plotted. Okay, so let's see. Yeah, it's moving just like that. And we can play a little bit with this function. We can have some kind of damped oscillation, so we can create a function y. Okay, and this y is going to be a function of I, so it's constant, like 5 times e, which is the exponential function, and the argument of this function is negative I times a factor, and this factor could be 2 for now, and then dot star for the element-wise multiplication, and then we multiply by cosine of I. Okay, and then we can plot I with y. If you don't like I here, you can just set it to x and then change it everywhere here to x. Okay, let's plot this one and see. Yeah, it's a damped oscillation, but it's very fast. It's going very, very fast. So we can decrease this a little bit. So let's make this 0.5 and see. So run, yes. It's not very quick, so we can decrease this even further, or we can also multiply by 10 here, and let's make this 0.2 and see what happens. So yes, this is the typical damped oscillation. Okay, and we can also do some changes, so we can have another function z. It's going to be the same. I'm just going to change this to sine. Okay, and we plot it here, and this is going to be blue. This is that. And now let's see how it works. You can see now that the two curves are moving together, because for each point here in y and z that are computed, this point is going to be plotted, okay, and this point is going to be plotted again, and this function is forcing the figure to be updated just now. Okay, so again, you can add different things to this figure. You can have, for example, here grid on. You want to have this outside the for loop. You don't want this command to be called a lot, even though you just need it once. And then you can also have x label as time, for example, and y label and so on. Okay, so if we run this again, let me close this, and we can see now that we have the grid and the x label, and again you can have the y label and the title and so on. Okay, one last thing before I finish this lecture, we have another command that sets the x limits and the y limits. Okay, so we can see here now that the limits from the x axis is from 0 to 70. Okay, we can force this to be from negative 70 to 70, or from negative 10 to 70, or whatever value. The function for this is called xlim, stands for x limit, and it takes a vector parameter. The first element in this vector is the initial point, so let's say negative 10, and the second is 80, for example. Okay, so if I do this, I have to close this first. Why I have to close this? Because if this figure is already hold and then it's not closed and I call hold again, this is going to be released. Otherwise I can just use hold on. So let's run and see. Yeah, so you can see now that we start from negative 10 to 80. Even though we start plotting at 0, but we can change the limit for the x-axis and the y-axis. Okay, this is the end of this lecture. I hope you enjoyed it. If you like it and if you feel it's useful for other people, please share it, and please subscribe if you haven't subscribed yet. Thank you, and hope to see you next time.